In this tutorial, we're going to learn how to build a web scraper with Go. To follow along, you will need to have Go installed. I will be using VS Code, but any text editor will do. In a new terminal window, let's change into the directory where our projects are stored. In my case, this would be the Sites folder. It may be different for you. Here, we will create our project folder called RhinoScraper. You can name it anything you like. Let's navigate into our RhinoScraper folder and create our main.go file. This will be the entry point of our app. We will also initialize Go modules so that we can handle dependencies in our current project. We're going to be using the Collie package to build our web scraper, so let's install that now. Once the installation is complete, we can open our project in the workspace. In main.go, let's set up a basic package main and func main. Let's switch into a browser to quickly examine the website we will be scraping our data from. These are some Rhino facts from factretriever.com. Let's scroll down a little to see what we're working with. From what I can tell, each fact has a simple structure consisting of an ID and a description. We can head back into our text editor and write a fact struct type to represent the structure of a Rhino fact. A fact will have an ID that will be of type int and a description that will be of type string. The fact struct type, the ID field, and the description field are all capitalized because we want them to be available outside of package main. Inside of func main, let's create an empty slice to hold our facts. We will initialize it with length 0 and append to it as we go. This slice will only be able to hold facts. We will be importing a package called Collie to provide us with the methods and functionality we'll need to build our web scraper. Using the Collie package, let's create a new collector and set its allowed domains to be factretriever.com. Let's go back to the FactRetriever website for a minute so we can take a peek at the HTML structure. The facts are list items inside an unordered list that has the class of facts list. Each fact list item has been assigned an ID. We will use this ID later. Now that we know what the HTML structure is like, we can go back to our text editor and write some code to traverse the DOM. Here, we are using the onHTML method, which takes two arguments. The first argument is a Go query selector, and the second argument is the callback function that will be executed every time our collector encounters a fact list item. The Collie package makes use of a library called GoQuery to interact with the DOM. GoQuery is like jQuery, but for Golang. Inside the body of the callback function, let's create a variable to store the ID of each element that is iterated over. The ID is currently of type string, so we will have to convert it to type int using a string conversion package from the Go standard library. I'm not sure how to say the name of the package though. strconv maybe? The ASCII to int method returns an error as its second return value, so let's quickly handle the error before we move on. If we get an error here, we will just print a log message saying we could not get an ID. Let's also create a variable to store the description text of each fact. Based on the fact struct type we established earlier, we are expecting a fact description to be of type string, so we don't have to do any conversions on it. Next, we want to create a new fact struct for every list item we iterate over. Then we want to append the fact struct to the all facts slice. We need to tell our collector where we want it to go and start crawling and scraping. So let's give it a starting point using the visit method. If we run our program in the terminal right now, there is no indication that anything is happening. So as a sanity check, let's print out a message with the URL that our collector is visiting. The onRequest method registers a callback function that will be executed every time the collector makes a request. If we run our program in the terminal now, we will see that our collector visited the Rhino Facts page on factretriever.com. Since we're printing requests to the terminal, let's also print out the Rhino info our collector is scraping. Let's import the JSON package to enable us to do this. We can use the package to create a new JSON encoder that writes to the OS standard output. We can then set our JSON output to be formatted with indentations. And then we can pass our all facts slice to our encoder so that it can be encoded into JSON. We should probably also import the OS package since we'll need it for our JSON encoder. The OS package provides an interface to operating system functionality. Now if we go back to the terminal and run our program, we will be able to see all our Rhino facts printed out as JSON data. Our web scraper works, but the data is not very useful if we're just printing it out into the terminal. Let's extend our program a little bit so that we're able to save the data we scrape into a file that we can use later. Let's create a function called writeJSON that takes in one parameter of the type sliceOfFact. Inside the function body, let's use marshal indent to marshal the data we pass in. The marshal indent method returns the JSON encoding of data and also returns an error. Let's quickly handle the error before we move on. If we get an error here, we just print out a log message saying that we were unable to create a JSON file. Now we can move on. To be able to write to a file, we will need to import the ioutil package. We can then use the writeFile method it provides us to write our JSON encoded data to a file called rhinofacts.json. This file does not exist yet, so the writeFile method will create it with the permissions code of 0644. To learn more about this permissions code, look for a link in the description box. Our writeJSON function is ready to use. Let's scroll up and replace the code we were using to print our Rhino facts out into the terminal. Now if we go back to the terminal and run our program, all our scraped Rhino facts will be saved into a JSON file. And there you have it. In this tutorial, we saw how we could build a web scraper with Go and the Collie package. I hope you found this video useful. Thank you for watching.